All right, we're going to get started now. So for this next lecture, we're going to be talking more about React. And basically, we'll review some old content from the past 2 days, and then we're going to talk a bit more in depth about some new React features that are really important and which we haven't gone over yet. So make sure to just go through the questions doc as usual if you need any, if you're confused about anything. All right, so let's start by just reviewing the component tree and why we want to use it. So one question you might have is like, when should you break down a component into smaller parts, right? Because we saw from yesterday that, for example, if you wanted to code Facebook, you could just have one big Facebook component with all your code in it. And like, when is this a good idea? When is this a bad idea? So as a reminder, a component tree is just an abstraction, which is like a tree, and it's a hierarchy of components, which represents the different parts of our web app. And so there are like several good indicators of when you might want to break a component down into smaller parts. The first one is just if you have like a really long code file and it's getting hard to read. In that case, you probably want to split it up into separate components. And you can think of this as, for example, if you're like designing a house, you don't want to have just one file with the entire house plan, because then if you want to like change some details, you have to like look through the entire file and it's really hard to find the one thing you're trying to change. Instead, what you want to do is have separate plans for the rooms, the floors, and stuff like that. Another good use case for breaking down components is this: if you just have like a component or a part of your app that naturally has a bunch of smaller parts inside, which each encapsulate their own functionality. So what I mean by this is like, let's say you're trying to build like, I don't know, a web app for a shopping mall. And so your shopping mall has like a bunch of different stores inside, right? And usually in most malls, the stores aren't interacting with each other. So each store will like have its own part of the website. And because these functionalities from different parts of the website don't interact, it makes sense to separate them into their own components. And that makes it easier to code them and also debug. And the last important use case is to control information flow between different sections of your app. So one problem you might have, for example, if you just have like one app component with all of your code in it, is that like if you do this carelessly, then you'll end up in a situation where like all your variables are in the same code block, and like any part of your app has access to any other information from other parts of the app. And that makes it very easy to write bugs. Instead, what you want to do is you want to make it so that each section of your website only has information, it only has access to the information that it needs to function, right? You can imagine like if you're trying to code Facebook as one app or like one component, and like each comment in Facebook has access to like all the user info from all the users, that would be like pretty weird. So yeah, in general, you should just think of the component tree as like a way to refactor your code to make your life easier when you're designing a web app. All right, so let's do some more review of different components. So this is the Quora page. And yeah, does anyone have any ideas for like the underlying components for this page? We've done this a few times already, so this should not be very hard. Yeah, someone said navbar. Anything else? Yeah, there are two sidebars, right? Sorry, what? Yes. Yeah, one of the navbars is, or one of the sidebars is a bunch of topics. Yes. Yeah, there's like also like the actual post in the middle, right? Yeah, so all those answers are correct. If we just look at some of these components, like the most prominent one for most social media sites is just the feed, which is like the thing in the middle. And the feed contains a bunch of posts, like you mentioned. And similarly, we have a navbar at the top with different links to other parts of the site. And we have left and right sidebars, as people mentioned. There's also a few other subcomponents. And yeah, so like you mentioned, the feed should be divided into like the compose box where you actually write a new question for Quora, and also separate posts. And similarly, the sidebar is split into different pieces. And I mean, so far, all we've done is identified like very obvious like visual separation, and like those are different components. There's also other components that you might not be as obvious. For example, we have a bunch of posts. If you scroll down in core, you'll find more posts, right? But all these posts are probably contained in like a wrapper, which is like a post list. And that makes it easy to support things like infinite scroll. But yeah, so those are just examples of different components you might find in a web page. All right, so now let's quickly review a bit more about states and props. And these are really important concepts. Hopefully you got a lot of practice with them over the past 2 days. If not, make sure to ask questions because like it will be hard to build a web app if you do not have this stuff down really well. Yeah, so the most important thing that I want to re-emphasize here is that you can't directly edit a component state from another component. And like we were talking about earlier with the component tree, one of the main reasons you actually want to separate code into components is specifically so that each component state is independent of every other component state. So the problem with this is that there are actually use cases where you might want one component to affect another component state, right? You can imagine, for example, if you have like a post component and then like the post has a child component, which is like a like button. And when you press the like button, like maybe the post component has like a state variable, which is like the number of likes. And you want, when you click on the child, you want that to update the parent state, which is the number of likes, right? So based on what we talked about so far, this isn't actually possible because what we're trying to do is we're trying to say when you interact with the child component, you need to update the parent state, right? So like, does anyone have ideas on how we could accomplish this without directly editing state from other components? Yeah. Yeah, what is the prop? Sorry, what? That's a good guess. So yeah, one thing you might think is like your parent component should just pass in like the state variable as a prop to the child component. This actually doesn't work because in the child component, like if you just like add one to the prop from the child component, it won't actually affect the state of the parent component at all. So what you actually want to do in this case is a workaround, which is usually referred to as a callback function. So I'll just show some code and we can talk through it. So basically what we'll do is we will pass, instead of passing the actual state variable from the parent component to the child component, we will pass a function which updates the state. So the way we do that is here we have a parent component and we have a cat happiness variable, and we define a function such that every time this change cat happiness function is run, it will set the cat happiness variable or state to be whatever it currently is plus 1. So this accomplishes like, this gives you a state update, right? And when we have a child component here, the prop we will pass in isn't the actual state itself, but it will be a function, which is the update function. And this update function is the change cat happiness function we defined earlier. And now, so that's our parent component. And in the child component, if we want to update the parent state, we'll actually call the props.update function. And props.update function is a reference to change cat happiness. So this will work the way you expect it to, and it will increment cat happiness by 1. And the important thing I want to emphasize here is that this is a workaround. Sorry, I did weird things with my leg. It's quite hard. All right, anyway. Yeah, so the key thing, wait, is this on? Okay, yeah. The key thing I want to emphasize is this is a workaround, right? Ideally, you don't want to do this very often because it could be very confusing and introduce a lot of complexity. Like, you can imagine a situation where like you have your parent component with some state in it, and you're expecting the parent component state to be like relatively stable. But like you have a bunch of child components with callback functions, and they keep updating like the parent component state, right? And if you have bugs, like if you have situations like this, it can lead to bugs where like your parent component state keeps changing and you have no idea why. So ideally, what you want to do is you want to design your component tree in a way that you have to do this as rarely as possible. So now let's talk a bit more about the difference between states and props. So as you guys have already learned, basically states should stay in some component and props should be passed down between different components in the component tree, right? And what that means is that if you have a bunch of information in your app, and we'll go over some examples later, if you have like information in your app that should appear in like 5 different components, what you want to do is you want to define that data in like the highest, basically in like a common ancestor of the component tree, where like all those components have a shared parent. And so it should be, so your data should live as a state in that higher component, and then you should pass it down as data to all the lower components. And we'll go through some examples of what that will look like. So here we have a Twitter app, and it has a bunch of components, right? Like the profile, feed, navbar, and there's individual tweets with comment and like buttons. So let's just assume that like your Twitter app, when you load it, it will fetch all this information, like your username, a list of posts, users you're following, and users you're being followed by. So does anyone have any ideas on like which of these kinds of information should be props and which components they should be passed between? Yeah.
I guess like the followed users and the followed by users should both be custom profiles. Profile and also username. I guess I don't know the list of like I don't see the list of posts is a problem. Well, I don't know if it's like the profile.
Oh yeah, that's basically correct. So basically, if we look at these different types of information, all of them should be props between different components in different parts of the web app. So if we look at username, for example, like your profile page in Twitter is going to display your username, right? And similarly, your feed is going to show your username at the top of the feed. So because of that, these two components, profile and feed, both need access to your username, right? So there's several ways you could implement this. One way is you could have like your profile has a function that like fetches the username from Twitter database. Similarly with feed. And this would be really annoying, right? Because you're doing the same thing twice. You're fetching the username in 2 different components. Instead, what you can do is in the Twitter app, which is the parent of both of these components, you'll fetch your username, and then you'll pass it in as a prop to both the profile and feed so that they both have access to your username. Similarly, for the other, for some of the other data, like your post list, you can fetch an app and then pass it in as a prop to your feed, and your feed will display all the posts, right? And if you have like followed by users and followed users, you fetch them in the Twitter app and then you pass them in to your profile so that you can show like your list of users. And yeah, so all of these should be props between different parts of Twitter app and the other components. So now let's take another look at the lower part of this tree. So here we have like an individual tweet, and each tweet has a comment box where you can type in comments, and it has a like button where you can like the tweet. And each tweet probably will also have some information contained in the component. So the tweet state will probably have like the poster, which is who posted the tweet. It will have the post content, which is like the actual text that's in the tweet. And it will have the post ID, which is like just an identifier for each tweet. Yeah, so based on this, like we have a tweet, which is a parent component, and we have 2 child components, comment and like. So which of these kinds of information do you think should be passed down as props from tweet to comment and like? Yeah.
So I guess like the post ID, I don't know. I would probably do like the comments are in the live associated with post ID, but as a prop, you don't really need to post it for content.
Right. So yeah, that's pretty good. So basically, yeah, that's correct. Basically, what will happen is that each tweet has the comment box and the like box, and like every tweet's comment and like box will look the exact same as every other tweets, right? So these components look the same, but they have to have different information because like if I press a like button for one tweet, Twitter needs to know to update the like count for that tweet. And if I press comment for a different tweet, Twitter needs to know to update the comments for that specific tweet. So the way you can accomplish this is with the post ID that the comment and like components each have access to. And that way, when the user interacts with either of these child components, Twitter will know how to identify which parent component the tweet is. And like you mentioned, basically, when we're looking at the poster and the post content, these are important information for the tweet, but for the purposes of the comment and like functionality, both of these don't actually need to know who posted the original tweet and who posts and what the post content is. They just need to know what the tweet, like which tweet it was. All right, so now let's talk a bit more about using state, and specifically, how do we modify state? So wait, did I skip a slide? Yes, okay, sorry. Let's talk a bit more about utilizing state. So as you guys saw from the previous workshop, this is how we define new state variables, right? We use the useState hook. And so the useState hook takes in one parameter, which is going to be the initial value of your state variable, right? And that will be loaded into like this, like if we say useState of empty array is like persons and set persons, then persons will be initialized as a state variable, which is an empty array. And then set persons will be a function that we can call if we want to update persons. And similarly for the other state variables, right? And the important thing to note here is that like, all we're doing here is passing in like arrays and false. Sometimes we pass in like useState 0. You can pass in any expression you want into this useState. It will just end up being the initial value of your state variable. So like if your state variable is some other data type, like I don't know, maybe it's some object like a car, then you can pass in like a car here. All right, so now we'll talk a bit about how to actually modify state. So this is also a review, so hopefully you guys know this already, but basically, yeah, you might be used to other programming languages where if you have a state variable which is exists, you just want to edit exists by like setting exists equals true, right? And we actually don't want to do this in React. Instead, what we want to do is use a special function associated with each state variable, which allows us to modify the state. So instead of modifying state, we will set state. And the way we do that is, so earlier we defined an exists state with a set exists function. And then we call that same set exists function here and set exists to be true. And the reason we want to do this instead of doing a direct state update is because this way this will basically tell React, if we call set exists, this will tell React that the exists variable changed. Whereas if we like just say let exists equals true, then it can cause problems for React because it might not detect the variable change until later. Here's another example. So we have defined a byDog function, and all it does is it takes the pets array and it adds a new variable or a new string called dog to the end of it. So one way to accomplish this is to just call the setPets state update function, and the new state we pass in is the old pets array along with a new dog element at the end. And an alternative way to do this using some syntax we learned from the JavaScript lecture yesterday is like this, right? So instead of calling pets.concat_dog, we will use the spread operator. And so just as a reminder, what the spread operator does is it will take this pets array, and the 3 dots means object destructuring. So what it will do is it will take the individual array elements in pets, and it will unpack them into like a bunch of elements. And then we add in this new element, which is dog at the end. And then we wrap this in a new array. And this accomplishes the same functionality as the previous slide. But in general, we will recommend doing this with a spread operator and object destructuring because like once you get used to it, this is just like a much easier way to see what's going on. Like I can immediately see, oh, 3 dots means I unpack pets. Whereas here, like reading pets.concat_dog is just, it's not as obvious what's going on. All right, so now I have a question for you guys. So here we defined a testing stuff function, and we have some person state variable, which is initially an empty array. And what we will do is we will do the same sort of array update as in the previous slide, and we'll concatenate a new element at the end called me. So after we do this state variable update, we will print the value of persons to the console. So does anyone have any ideas on like what the console will log? Like the two choices are it could log an empty array, which is the old value of persons, or it could log an array with one element called me, and that would be the new element or the new update, the updated value. Yeah. Okay, so someone said B, which would be the new value of the person's array. Does anyone have a different opinion? All right, that's fine. Oh, yeah. That's also a good guess. So yeah, this setting persons to be like the old value of persons in me will actually update persons. So the right answer is actually that we don't know what the console will log when we print persons. And the reason for this is because basically what will happen when we run this JavaScript code is, so this set persons function is asynchronous. So what that means is that when we run this code, we will do a function call to set persons, which updates the person, right? But this set persons will take some time to finish running. And in the meantime, we're going to immediately also call this console.log, which will print the value of persons. So what this means is that sometimes set persons will finish updating persons before console logs persons, in which case you'll get B. And sometimes before this set persons finishes, this console.log will already have started, in which case you'll end up with A. And probably in practice, what will happen is most of the time, if you try this, you'll end up with A because this takes some time. And also because React will generally try to take a bunch of set state updates and like batch them together to improve performance so that you don't have to render as many times. And yeah, basically, we just don't know what's going to happen here. So this is pretty annoying, right? Yeah, so just remember that setting state is async. And if you want to update a state variable and then use it later, we have to do a special workaround for that. So you might ask, like, this is pretty dumb, right? Because it's pretty common to have a use case where we want to update a state variable and then like use that updated value immediately afterwards. And like the use case we just described is a reasonable example. So if we want to perform this kind of like computation after we update a state variable, we need a new React feature for this, which is use effect. And I will talk about that later. But yeah, the important thing to note here is that we haven't actually learned any way to do this sort of waiting for an update and then doing computation on the new value yet. So before we talk about what the use effect hook does, we're going to review just like basically how React components work, like the lifecycle of a React component and like the timeline for how updates and rendering work. So here's like how you might intuitively imagine a React component to work. What will happen is we start by initializing our component, and then what happens is like after we initialize the component, it returns some value of the component, right? And then every time we have a change in state, we will update the thing we're returning, and that will trigger a new render, and like we keep on having state updates and new renders, right? So that's like a pretty good high-level understanding of like how the React lifecycle timeline works. And in practice, what happens is going to be slightly more complicated. So basically, what we're going to do is call the constructor on the component, and it will return some initial value. So you can think of this as, for example, like when you have a bunch of useState expressions, like that sets all the initial values for the state variables, right? And then this return is going to return whatever the component evaluates to using all those initial state variables. And this is called mounting the component. And after we do this initial mount, then we're like waiting for state and prop updates, right? So now we enter the second stage of the React's component lifecycle, where it's just an infinite loop. And what happens is that all we're doing here is we wait for states or prop changes. And whenever those things change, we return something new and we render something new. And then we go back to waiting. So that's how React's components work. And we're actually going to add a new portion to this diagram now. And this will be the useEffects hook. So what it will do is it will work similarly in the sense that like whenever a state or prop changes, we'll do some other updates. And I'll explain what those updates are now. So useEffect is a React hook that takes in two parameters. And it will take in a function and an optional dependency array. And basically what it will do is it will run this function after specific variables in the dependency array change. So some common use cases for this are like basically like we were talking about earlier, you have some state change and you want to have some other responses to that state change. Another common use case is if you're just trying to load a bunch of data into state. So loading data through like an API call, for example, could take a while. So what you'll do is like you'll put the code to load that data in a useEffects hook, and then like you'll only run that once. And other examples are like other computations or APIs that you want to only run at specific times. If you only want to run these computations at specific times, you put them in the useEffects hook. And what it will do is it will take this first parameter, which is a function you pass in, and it will run this function only after any of the variables in this array change. And that might be a bit confusing, so we'll just go over some examples of what that looks like. So in our previous, like a few slides ago, what we were trying to do was this, right? We were trying to update persons by adding a me at the end. And after we update the value of persons, then we wanted to print persons, right? And what we were saying earlier was that this might or might not work because console.log might not happen after set persons. And so the way we can accomplish this successfully is with the useEffects hook. So we will define this testing stuff function similarly to earlier. And what it will do is it will update the value of persons. And now, instead of doing console log right after this person's update, what we will do is we will put this console log in the useEffects hook. So the function we're going to pass in to useEffects is just a function that prints persons. And the dependency array that we give to useEffects is persons. So what this will do is React will know that every time this person's variable changes, we're going to run this function which prints person. So like if you call testing stuff a bunch of times, it will keep adding me to the end of persons. And each time after persons updates, then we will log the value of persons. And this ensures that we're always working with the like up-to-date value of persons. Yeah, does that make sense so far? Any questions? Yeah.
Should there be semicolon at the end of that?
Oh, yeah, sorry about that.
And is the other semicolon going to be there? Does it matter?
Yeah, that semicolon should be fine. Yeah. So some other examples of use cases for useEffects. We're just going to be talking about different examples of dependency arrays you can pass in. So let's say instead of like, so here what we're doing is every time persons changes, we're like printing persons, right? And if instead of like waiting for one variable to change, you want two variables to change. So like here we want to run this function every time variable 1 changes or variable 2 changes. It's either of them, not both. If we want to do that, then we will pass in a dependency array with variable 1 and variable 2. Similarly, if we only want to run this function once, and after other variables change, we don't care about those variable changes. We only want to run this function once in the lifecycle. Then we will pass in an empty array. And this empty array just says that like, I don't care what state variables are changing, right? All I want to do is run this function once at like the beginning of the lifecycle. So this second case is useful, for example, if like your component is loading a bunch of data and you don't expect that data to change throughout the course of the component's lifecycle. Like, for example, I don't know, maybe you're like loading like today's like top headlines or something, and like those will probably stay the same throughout the course of the day, right? So here, like, yeah, so basically if you want to load some data once, you will use useEffect with an empty array. And another example is, so earlier I mentioned that this second parameter, if you pass into useEffect, is optional. And if you just don't pass in any dependency array, what this will do is React will basically assume that like, if you're not passing in a dependency array, that means that anytime any state variable changes, you want to update, you want to call the function. So if you use this if you do this last case, then what will happen is like, whenever any state variable changes, we'll call function. And we generally don't recommend this because your state variables could change many times, and it might not be obvious when they're changing. Like maybe you have a parent component which has a prop, and that prop change triggers a state change in your component. So basically, if you do this, like your function will run many times because your state will change many times. And yeah, you probably don't want this to happen unless you have like a good reason for it. So basically make sure you pass in the right dependency array for your use case. Basically what you want to do is like, if your function depends on certain other variables, you want to put those variables in your dependency array, and you don't want to put other variables inside. Okay, so now we're going to talk a bit more about stuff from Noah's lecture just now before lunch. And specifically, yeah, we were talking about get and post requests, right? So if you look in the later workshops that we will be doing, we will have defined a utilities.js file. I think this will start in like workshop 3, basically. So you might not have seen it already. But yeah, this utilities.js file will contain code that the Web Lab staff wrote for get requests and post requests. And the way it works is you just type in get with your API endpoint, along with any parameters you want to pass to the get request, and that will trigger the get request, right? And then the get request returns a promise. And after we get the result from that promise, we can do stuff with it. Here we're just printing it, but you probably want to do something else in practice. So earlier I was saying that, like, for example, if you want to load in some data at the very beginning of your lifecycle, your component lifecycle, you put it in a useEffect. And so here's an example of that. We are getting some initial package data from this packages API endpoint. And then after we get that data, we move it into state using the set packages state update. So what this will do is it will just ensure that, like, one time at the very beginning of your lifecycle, you'll update the packages state with the data that you got from the API, the packages API endpoint. And this is useful if you just have like a bunch of data that you're trying to load from your backend into your state once, and then you like reuse that state over and over later. So similarly, if we want to send data to the backend, we will do post requests instead of get requests. And the syntax for that will be very similar. Here's an example where we just have a button, and every time we click on the button, we're going to like change some user's admin status. So if we want to change a user's admin status, two things need to happen, right? The first thing is that on the front end, we should change their admin status from like true to false or false to true. But the other thing that needs to happen is that in the back end, like, we're probably storing all the admins in some database. And what we need to do is like, we need to tell the database that this person is no longer an admin, or now they're a new admin, right? So we need to perform both of these updates. So the way we will do that is like this. We will perform a post request to some API endpoint where you can change admins. And what we will do is we will pass in a parameter telling the API that the admin value has changed, right? So this first part with the post request is only going to update the backend. It's not going to update the value of admin in the React front end. So after this post request finishes, then what we can do is we can take this admin state variable and we can toggle it, right? So this will set admin either from true to false or false to true. And the reason we want to do this is the reason we like this pattern of first you do the post request and then you change the state is because you could imagine a scenario where, basically the reason this is good is because it makes sure that the front end state never runs ahead of the back end, right? Because you can imagine a scenario where like you're doing a bunch of backend requests and like a bunch of backend updates, they all take some time and maybe some of them fail, right? So if some of these updates fail, you don't want to just like be updating your front end state in advance because that can lead to a lot of bugs. So instead, what this will do is this will wait for the backend to update, and this ensures that your front end state and your backend state remain in sync. All right, so that's mostly it for the get and post requests. Now we're going to talk a bit more about some useful JavaScript syntax and tips. So here's an example of JSX, and like we learned earlier, JSX is just a way to take HTML elements and load them into JavaScript and vice versa, right? So here we're defining a JavaScript variable, but this JavaScript variable is actually an HTML element, right? And it says that you should follow me on Twitter at @vvhuang_, which you should actually do. And afterwards, yeah, anyway, so we can also do this for multiple pieces of content. So here I have defined two JavaScript variables, right? There's a header and a content, and these are both HTML tags. And maybe what I want to do in my React component is I want to return both of them, right? So if you just return like header and content, that's not going to work because each component can only return one thing at once, right? So instead of returning two HTML elements, what I need to do is I need to wrap both of these elements in an outer div tag. And basically, if you wrap both of these things in one outer div, that counts as like now you only have one HTML element. So this will allow you to return multiple pieces of content at once. And this will just return like a header which says, I love Kevin Tian, and the content which is uwu at the bottom. So yeah, and like we saw earlier, so this is if you like if you have an HTML environment and then you use these curly braces, the stuff inside is going to be valid JavaScript. So this allows header to reference the JavaScript variable here, and so on for content. All right, so now we have another common use case where like, depending on the state of the component, we might want to return different things, right? So here's an example where we have a page, and maybe the page like has to request data from the backend. So the page is going to take a while to load the data, right? And what that means is that when the page is loading data, we want to return a loading screen. And when the page is done loading the data, we just return the actual page content. This is like a very common pattern that you see in a lot of websites. And a lot of times websites that don't do this, they will look like really bad when you're like initially loading the page because none of the data has been loaded, right? So it'll just like be this weird empty thing. So here's an example of how you can do that. So what we're doing here is we're using this ternary expression, and the syntax for this is you have some Boolean, which is a condition, and you have a question mark. And after the question mark, there's two expressions. One is the result if true, then we separate it by a colon, and then we have the result if it's false. So what this will do is JavaScript will evaluate the condition. If it's true, it will return the first thing. If it's false, it will return the second thing. So if you want to render different pages depending on what your state is, this is an example of how you do that. So here, if loading is true, we're going to display a loading message where we just tell people to buy Bitcoin. And if loading is false, we're going to display the actual page content. So this is like a common conditional rendering pattern. Does anyone see a way to actually like make this code better? Like just think about like if you were writing this code in practice, like what do you not like about it and what would you change? Yeah. Right. So basically what happens here is like the divs and the pages we're returning are almost the same, right? The only difference is like the structure is the same, the title is the same. The only difference is that we have this like loading message and here we have the actual content. So if we want to write this more concisely, one way to do that is like this. Instead of writing out the different return expressions entirely, we will just write out one return expression. And basically like the stuff that stays the same between the two cases, it can just be written in regular HTML. And the only thing that will change between the different cases where loading is true or loading is false is this content, which is in JavaScript. And this content will just, so basically all we've done here is we take the part of the page that is changing between states and we put that in its own JavaScript environment. And then we reference that in the HTML. And if you actually want to go one step further, you can integrate this even more nicely like this. So here we're doing a similar thing where we're returning a bunch of HTML. And the only thing that's changing is like this loading message versus the actual page content. And so we just, all we do is we put that in the braces to indicate that it's JavaScript. Does everything make sense so far? Any questions? All right, cool. Oh, yeah.
How do you actually do the loading? Like for like how would you have it? How would you know it's loading or not?
Right. Usually the way you'll do it is, all right, the question, by the way, is like, how do you know if the page is loading or not? And usually what you'll do is initially when the component is initialized, you set the loading state variable to be true because like it's the start of a life cycle, right? And then like you're loading in data from the backend. So what you'll do is like you'll do a GET request to the backend API. And after that API returns a result, then you like set loading to true after receiving the result. And that ensures that loading is only true after you receive the data. Does that make sense? All right, cool. Yeah, so now let's talk about another common pattern. So this is loop rendering. And basically what happens is like we have an array of data that is in JavaScript and we want to display all the data. But the issue is that you can't just display an array in HTML, right? Instead, what you need to do is you need to return actual HTML elements. So we need a way to map this data from JavaScript to HTML. So the way we'll do that is with the map function. This was talked about briefly in the JavaScript intro lecture yesterday, but I'll just go over it again because this is like a very common React pattern. So basically what happens is what the map function will do is it will take some original array, here that's my array, and it will also take some function as a parameter. So here what the function does is it takes an element and it returns 3 times the element. So when we call a myArray.map with this function, we'll end up with a new array. And this new array is just applying this function to each element of the old array. So what we'll end up with is a new array where all the elements have been tripled. And you can do this with basically any other function as long as it is like takes one input and returns one output. So that's like the general map pattern. And if we want to use this in React to render an array of data, this is how we'll do it. So here we have like an array with a bunch of data, and these are all different users, right? We have Dan, Daniel, Danny, and Daddy. And what we will do is we want our HTML page to like render all of this, right? So the way we'll do that is React doesn't know how to render all these JavaScript arrays. So instead, what we have to do is we have to give each of these array elements its own div, right? And the way we do that is we'll use map, and for each map element, we'll return a div. And So I'll show you guys like the actual code you would do for this different example. And yeah, basically once we have these divs, React can actually render this because it's in HTML, right? So what this looks like in practice is we have some data with some messages in it, and we want to display all the messages on our page. So what we will do is we will call data.map. And for each of these items, which is an array element, we will return a div. And each div will have some key, and it will have some text inside the div. And the text is like the item.text we got from the array. So this way, basically, we have an array of data, and this allows us to like render a list of divs that each have the text we want. So that's an example with just plain HTML. And we can also do this with general React components, right? So here we're going to do the exact same thing, except instead of a bunch of divs, what we'll do is we have some components that we define somewhere else in the component tree. And what this code will do is it will basically create an array of child components. And so now we have a ton of child components, and you can do whatever you want with the child components. So this is just like the most general pattern for if you have an array and you want to turn it into a bunch of React components. And just as a side note, a more concise way to write this is you can like eliminate the braces in the return statement, and you get like an equivalent but slightly nicer syntax. All right, so that's all the most important stuff we had to cover. Anyone have any questions? Yeah. This one? Yeah. Okay. All right, well, if there's no questions, I'll just show some optional slides really quickly. These aren't that important, but they might be helpful for specific projects. And we're running low on time, so I'll just go through this really quickly. So some other JavaScript features we haven't talked about yet are if you want to use math functions, JavaScript has a math object. Probably the most common things you'll use are min and max to compare different numbers. And if you want to do like fancy math, there's some of that too. Similarly, a lot of apps will have to keep track of dates, right? So for example, if you're building a calendar app and you like want to remind someone like, oh, in 1 week, I want to send this reminder, like it's really hard to implement calendar logic on your own because like, for example, if I say like, I have some current date and I want to know the date in 7 days, that depends on a lot of stuff like the month of the year, whether it's a leap year, stuff like that. So instead of having to implement that logic ourselves, we can use this JavaScript date object, which has all this stuff already done for you. So for certain kinds of apps, this will make it a lot easier. Similarly, we talked about storing data using arrays and objects. Arrays are just like ordered collections of elements, and objects are a bunch of key value pairs. Sometimes you also want to only keep track of distinct values, in which case you can use sets, which are also in JavaScript. And this works in the same way as in Python, where if you add the same element multiple times, it only uses it once. Finally, we have some JSON stuff. So basically what this will do is it allows you to take an object in JavaScript and turn it into a string. And the reason this is useful is because, so like I can call JSON.stringify it to an object and it will turn it into a string. And if I want to retrieve the original object, I can call JSON.parse and that will return the original object. And this is useful, for example, if you look at our utilities.js code from workshop 3, which will start soon, the get and post request will do this to turn the parameters into a string. And also, if you want to like store an object in a database, sometimes it's easier to just store it as a string and then retrieve it whenever you need to. And finally, if you want to learn more about React, there are other features that we haven't covered. Also, the hooks reference in React just like has more details on how to use useState and useEffect. Sometimes it can be confusing, so I recommend this reference. It's very easy to understand. And it also has additional React features that we won't talk about for like improved performance. And yeah, all right, we're actually done now. Uh,